Fab.
And I'm Lo.
And today we're going to be talking about
the gas chromatograph mass spectroscopy.
Hello and welcome to Alfred State's Instrumentation Lab. And in this lab, there are various instruments such as the FTIR and IR, the GC and the GCMS, UV-Vis, AAS, and many other instruments used to identify various components. Today we're going to be talking about the GCMS, and specifically, Bob.
Hi everyone. I just want to talk a little bit about our GC portion of the instrument. And this portion right here is actually our injection port, and this is where you would inject your sample, and you would use either a wet needle injection or a syringe injection. So now I'm going to briefly show you the actual injection devices that you would use. So first, this is our needle, and the way that you would use it is you would take your sample and you would swirl it inside your sample. Afterwards, you would take this needle and you would stick it inside of your instrument like so. Take it out and press start. This is your syringe. So this syringe actually is calibrated with the exact amount of solution that you could use. For example, this is calibrated to 0.5 milliliters. So you would just take your syringe, you could put it in your sample, you would then pull this up, and then once you feel it stop, that means that you have the correct amount of solution within your syringe. Then you would take it, you would put it in your injection port, you would press down, and then press start. So this part of our instrument is actually called our oven right here, and this is where actually all the magic happens. There's a circular piece within our instrument that I will briefly show you. So this piece here is actually called our open capillary glass column, and it is 0.2 to 0.3 millimeters in diameter. Our oven also has a inert gas that helps the sample go through the column. This gas is also known as our mobile phase. We also have a stationary phase, which is coated on the inside wall of the capillary column. The sample is injected, and then the helium actually helps the sample pass through the column. Each compound of the mixture interacts with the column at different rates, and the compounds have lower melting points, so they will interact with the column the fastest. And then they will exit the column and go into our FID detector, which stands for flame ionization detector. And this detector is good for detecting alkanes, alcohols, ketones, aldehydes, ethers, and low-weight aromatics. However, it is not good for herbicides, pesticides, organic acids, and large weighted aromatics. Our FID detector then detects the sample, and it measures the ion current by burning the sample using H2 and O2 flame. Our FID then makes an electronic signal, and the more concentrated the compound, the larger the signal will be. This signal is then read by our computer, and then the computer generates a chromatogram.
Now we're going to talk about the mass spectrometer. Here we have the mass spectrometer on Bob. And what the mass spectrometer is used for is used to identify and quantify various mixtures. And it does this by electronically charging the molecules and accelerating them through a magnetic field. This breaks the molecules into charged fragments, and the MS is used to detect all of the different charges. It then uses this information to construct a plot that displays the mass of each fragment. And now these fragment masses can be used to find the mass of the original molecule, also known as the parent mass. There are three major components to the mass spectrometer. First, we have the source, next we have the quadrupole, and then we have the detector. The source of the MS is called the electron impact, and it uses a magnet to focus the beam of ions that is being passed through, and it separates them by their charge and mass. Next up is the quadrupole, also known as the mass analyzer. The quadrupole has 4 electromagnets and it acts as a mass filter. What it does is it focuses each fragment through a slit and into the detector as the mass range is being scanned. Next up, we have the detector. The detector is called the dynode detector, and the detector detects every ion that passes through the quadrupole. So the GCMS contains 2 different types of gauges located in the back of the instrument. The first one is called the thermocouple gauge, and this measures the various temperatures that's created by the gases and then is converted into volts. Next up is the Phillips Granville high vacuum gauge, and what this one does is sends a current between the anode wire and the cathode loop, and it measures the conductance at a fixed voltage.
So now I'm just going to briefly show you how to run your sample. First, you would go to Method. You would go to Edit Entire Method. You press OK. Press OK again. Press OK. So now this area is where you can actually change some of your conditions. So I'm just going to briefly look at a couple of things. I'm going to make sure that my split ratio is all right. So we are at a 10:1, so we're completely fine. Next, I'm going to look at my column. My column, I have a flow of 0.9. I'm going to also look at my oven, and this is actually where you can change the temperatures of the thermal ramp. So currently it is set to 60, so I'm just going to change it to 40, and that is the lowest you can go. You can also change the ultimate temperature. I'm going to change it to 250. Then you just press apply, and as you can see, the thermal ramp has changed. It's going from 40 all the way to 250. I'm just going to press apply and OK. I'm going to press OK again. Okay. Solvent delay is very important, so you can choose the amount of delay you want. In my case, I'm just going to do 1 minute. I'm going to press OK. Now, you always want to make sure that you do your method file. So I'm just going to label mine as fab unknown, and all your methods need to end in .m. I'm going to press OK once again. Now I'm going to load my method. So I'm going to go to method. I'm going to go to load method. I'm going to find myself. I'm right here, fab unknown.m. I'm going to press it. I'm going to press OK. Now my method has been loaded and my oven temperature is slowly changing. So you just want to wait until you get to the temperature that you set it to. I set it to 40. Now I'm going to go to my data file. You can change your data file name. I'm just going to keep it as fab unknown 11.d. All your data files need to end in .d. Finally, you can press OK and run method. After your method has been loaded, you will receive this text box. So it's just telling you to first make sure that you press prep run on your GCMS. And prep run just lets you know if the GC portion of the instrument is ready to receive a sample. Afterwards, you would just press start.
Before you want to inject your sample, you have to press this button called prep run. So when you press the prep run button, it'll start blinking, and once it stays at a steady light, you know you are ready to run your sample. Unless this light is on, then that means you cannot use the GC. Today we're going to be using the syringe as mentioned before, and here we have our sample. So I'm going to grab some of the sample by pulling the top up. You always want to make sure that the liquid is in there by dispensing some of it back out. And now I'm going to inject it into the GC, dispense the solution, and now press start. If this text box comes up, you always want to make sure you hit no. Now, the GC will run for about 11 minutes.
After your sample cycle has been completed, you'll get a couple of pop-ups. So this just kind of tells you a bit of a summary of what could be in your sample. So I'm just going to exit them out. I'm going to minimize this, and I'm going to go to the desktop and go to data analysis. Now I'm just going to try to find my data file. I am right here. So now you have to right click and you're going to load your data file. So now, as you can see, I have a couple of small peaks and 2 very large peaks. So if I want to see what these 2 large peaks are, I would just left click and then drag a box over this peak. This just zooms in on that specific peak. Now I'm going to center this line and I'm going to right click. Afterwards, I'm going to click on select and search. And as you can see here above, this is the name of my peak. Now I'm going to do the same for the next peak. I am going to right click. I'm going to hit redraw. It's just going to show me my entire chromatogram once again. Now I'm going to left click once again, make the box. And I'm going to try to put this line in the middle as best as I can. I'm going to right click, select and search. And now it's telling me that my second peak is caffeine. Now I'm just going to read. So this top graph actually shows you your chromatogram, which is produced by your GC. And this bottom portion is your mass spectrum, which is produced by your mass spectrometer.
Hello, thank you for watching our video.
We hope it was educational and it answered any questions that you might have had about the GCMS.
Bye.